our last lesson, kind of, in this unit, which is identifying if an ordered pair is a solution to an equation. What an ordered pair is a point. You did that last Friday. It's a point that looks like this, x, y. X is always first, y is always second. And to identify if an ordered pair is a solution, you need to know what solution is. A solution makes an equation true. We also did that last week. We identified if x was a solution to an equation. So, our application with this today, it's pretty much one thing we got to do. Determine if the following ordered pairs are solutions to the following equations. This is how. You plug the x and y in and see if it's true. Plug the x and y in and see if it's true. So, for y equals 4x, what some students need to do at first, and you won't always need to do it, you'll have to write the x and the y down. Remember, the first number is the x, the second number is the y. So the x goes to the x, the y goes to the y. I write it down. Does 8 equal 4 times 2? Yes or no? Does 8 equal 8? Yes, it's a solution. It's true. So notice my strategy. Remember, the semicolon is the same as the previous lesson. The semicolon just means for the point 28. Here I want to know, does y equal 3x minus 2 for the point 37? Well, you need to know what x and y are. You put the x where the x is, you put the y where the y is, and you rewrite. Does 7 equal 3 times 3 minus 2?
Yes.
Yes.
Yes, it sure does. 7 equals 7, definitely. In the next one, the first point is the x, the second one is the y. X goes to the x, y goes to the y. Rewrite. Does 4 equal negative 1 plus 5?
Yes.
Okay, so that's kind of horrible examples. They're not always going to be true. Okay? We are going to get some false ones in there sometimes, just so you know. They will not always be true. Okay, the next one. Tell whether the given equations are, or the given ordered pairs are a solution. Remember, the semicolon means for. The first one is x, the second one is y. That will never ever change in your whole entire life. It will always be x, y. Always. 3 goes here, negative 5 goes here. Rewrite. Does negative 5 equal 3 minus 8?
Yes.
Another yes. Maybe I'll have a no in here somewhere. I don't know. Okay, the next one, fractions. You're going to have fractions. You can't scoot away from the fraction. You have to embrace the fraction. Y equals x plus 2/3 for the point 1 1/3. So that's my x. The 1/3 is my y. Does 1/3 equal 1 plus 2/3? 1/3 does not equal 1 2/3. Hey, we have a no.
You got your wish.
I did. This next one is, I'm bumping up the rigor with this next one. Because I have these negative signs. So with the negative signs, it definitely bumps up the rigor. X, Y. X goes to the X, Y goes to the Y. Does negative X is a negative 4.2, equal Y?
No.
Negative and negative turns to positive. 4.2 does equal 4.2. Yes, it's a solution. So I want you really reflecting right now, how do you feel about checking if an ordered pair is a solution? You're gonna have to show some work. You're gonna have to remember the main concept that a point is always x and then a y, and then know how to plug it in. Last one that we'll do, x, y, x goes to the x, y goes to the y. Does 3 equal 2 times negative 2 plus 7? Does 3 equal negative 4 plus 7? 3 does equal 3, so another solution.